Okay, so for today, we theoretically have very little to do. Um, it's just more about the fact that, some of you probably are falling behind on work. I basically saw a handful of people who are pretty much up to the unit test. And there's just a little tiny bit left for us to go over. If you got my message today that I sent out, what I decided to do was like having one less day of class doesn't really sound like a big deal, but when each day of our class consists of so much, work, I didn't necessarily feel right about just piling on everything for you guys. So what I decided to do is I'm going to add 20% to your grade for the homework. And the reason for doing that was to make the end of unit test kind of optional. So if you guys are having trouble getting your work completed or catching up, excuse me, then that way, I wouldn't make you feel like you're obligated to do it. So your grade can go up to 100%. So as soon as you get to 80%, then that's pretty much all the highest you can go for score. You are welcome to do the end of unit test in Khan Academy as many times as you want, because that's always a great way to kind of review the questions that were in the unit. Whatever it is. So we only have one topic left to cover. And once we cover that, I'll kind of leave it up to you guys as to how you want to go, for today. So the one topic we have left is all of the trig derivatives. We've already learned 2. So the 2 that we've already learned are that the derivative of sine is cosine, and that the derivative of cosine is negative sine. Well, we already know that there's 6 trig functions, and so that means there's going to be 6 trig derivatives. What I'm going to do is I'll show you guys how we come up with the other trig derivatives, but we're not actually going to do all 6 of them. Or the other 4, I guess I should say. I'll show you how we come up with tangent. So the first 2 trig derivatives that were discovered were sine and cosine. And for quite a while, those were the only 2. And then once somebody discovered the product rule and the quotient rule, so basically once those were come up with, shouldn't even say discovered. It's not like they were there and then somebody just found them, So once somebody created the product rule, quotient rule, well, then that fully allowed you to find all of the trig derivatives, because tangent can be written as sine over cosine. And if you write tangent as sine over cosine, then that's a quotient. And so we can use the quotient rule to find this derivative by writing it as sine over cosine. So quotient rule was g f prime, so derivative of sine, minus f g prime, which I should delete this line over here. And derivative of g is negative sine, all over g squared. Well, the numerator turns into cosine squared plus sine squared. And then cosine squared plus sine squared equals 1. So the derivative of tangent is 1 over cosine squared, or secant squared. And so this method that we just did, you can use this method to find all trig derivatives. Now, I'm not going to make you guys go through that. And to be honest, you're not going to be expected to do this for tangent. So it is fully acceptable and allowed. Wait, did I delete that too quick? Should I put that back up? I can't see anybody's faces, so if you want me to put that back up, I can hit undo. Okay. I mean, I could still hit undo, so. What I'm going to do is I'm just going to give you all 6 trig derivatives. And then these are the 6 you have to know. So the derivative of tangent we just did was secant squared x. Derivative of cotangent is negative cosecant squared. Derivative of secant is secant tan. Derivative of cosecant is negative cosecant cotan. Okay, now I laid these out badly. Let me group them together slightly different, because I want you guys to see the pattern. So I'm not going to pretend that I know how the AP test is going to be set up this year, because last year 100% threw me for a loop. I fully never expected them to allow you to take the test at home, for 1, and then for 2, you were allowed to use anything on the test. So you didn't have to memorize anything. The normal AP test, which they told us that they were planning on giving a normal test, you know. But if factors change, then they will do something different. Well, the normal AP test, you have to memorize everything. You're given 0 formulas. And that's usually a huge deal for some people, because there's a lot of things to remember. Well, the trig derivatives have a pattern. So you probably remember, do you remember hearing the word cofunctions back in pre-calc? These are cofunctions. So we've got sine, cosine, tangent, cotangent, secant, cosecant. So I've grouped them by cofunctions. Well, sine and cosine actually are the 2 that don't really follow the pattern. But, so say we figured out tangent's answer was secant squared. Cotangent's answer is negative cosecant squared. So it's the cofunction. The derivative of secant is secant tan. Its cofunction answer is negative cosecant cotan. So basically, if you can remember a couple of the derivatives, you'll be good for all of them, because they go in groups. And, you know, one's positive, one's negative. Honestly, sine and cosine are the only ones that don't fit it perfect, because sine should be up above for the pattern to match. But sine and cosine are easy enough where it doesn't matter. They're kind of like automatic. So tangent, if you memorize tangents, which you can always do quotient rule if you can't remember it. So if you memorize tangent and you memorize secants, you'll have them all. But that's only if you have to memorize. So that's why I preface this by saying I'm not going to pretend to know how the AP test is going to set up this year. If it's a normal test, you have to memorize everything. And that's a huge, huge stumbling block for a lot of people. I don't know what their reasoning for it is. Because I'll blatantly tell you, I don't have all of it memorized. I've used it myself multiple times. I've used everything multiple times. And I don't have everything memorized. You look things up when you need them. I mean, that's how it works. So, you know, but I'm not the one that makes the test. So I just try to prepare you for it. Does anybody have any questions on any of these 6 that are up here? And I don't even know if you need me to do any problems with you guys. They work exactly the same as sine and cosine do. If you have a multiplier in front of it, you use the multiplier. Otherwise, this was the only topic we hadn't covered yet. And I easily could have thrown it in yesterday. I just, because of time, I didn't want to add it on top of everything. I can. I certainly can. Let's do a semi-difficult one as our example. Because if I do a regular one, honestly, I don't think it's going to help anybody. So let's do a product rule. No, I was about to put sine. I don't want to make it ridiculous, so sine and tangent? Maybe I should make this like cosecant tangent or something, so that it's only new ones we've done. You bet. So I'm assuming you have a TA84, right? Yeah, okay. So the newer calculators, the Inspire ones, actually do have the button on them. Now, are you asking for derivatives or just like calculating angles? Well, your 84 can't really do derivatives like that. It can only find numeric derivatives. I'm trying to think of a good way to explain it, you know, without being there next to you to show you the calculator. So you type 1 over, you know, like, so if you're trying to find the derivative of secant on the calculator, you can just type in the derivative of 1 over cosine. So you would basically just write them all in terms of sine, cosine, and tangent, because those are the buttons you have. And it calculates and works fine. Mm-hmm. So if we're doing product rule with cosecant and tangent, let me scroll up so you guys can try to see that works. Get them both at the same time. So product rule is going to be the first. And I flat out don't have room to do f prime, g prime underneath, so I'll try to just write this. So the product rule is the first item times the derivative of the second, which in this case, the derivative of tangent is secant squared, plus the second times the derivative of the first. So the derivative of cosecant is negative cosecant cotan. Now, part of the reason I wanted to pick a product rule with trig is I don't know if anybody realizes what usually is going to happen on these. There's usually a crazy amount of simplification. And that's the annoying part. Does anybody have any questions on the actual product rule first, though? Like what I have highlighted? Because I'd like to answer questions on that for sure. Like, I don't know if everybody got that part okay. I mean, if so, that's awesome. So the simplification part is generally the easiest way to do it is to change everything into sines and cosines and see how things cancel or combine. So I'll do that to start with. So cosecant would be 1 over sine. Secant squared is 1 over cosine squared. Tangent is sine over cosine. The negative, I'll actually change the plus sign to a minus sign. And then that way, I don't have to worry about the negative. Cosecant is 1 over sine. Cotangent is cosine over sine. So I'm basically just trying to write them all into similar terms to see how things go together. And so cosecant secant squared doesn't do anything. I mean, like, nothing cancels. But the second term definitely does. I've got a sine and a sine. I've got a cosine and a cosine. And I'm actually left with just 1 over sine. So I can do this different ways. I think what I'm going to do is just change everything back into proper form so that it's not sines and cosines. So this first one, nothing happens, so I'm just going to leave it the way it was. The second one, the only thing remaining is sine on the denominator, which would be cosecant squared, cosecant. This would be an acceptable answer. It would also be an acceptable answer to factor out cosecant. Ooh, you know what? Secant squared minus 1 might change into something. I don't remember. So what do we got? We have sine squared plus cosine squared equals 1. Divide by sine squared, I'd get 1 plus cotangent squared. 1 divided by sine squared would be cosecant squared. Divide by cosine squared, tangent squared plus 1 equals secant squared. It does. So secant squared minus 1 is tangent squared. So the fact that we were dealing with squares gave me a heads up that it might be Pythagorean identity. So secant squared minus 1 changes into tangent squared. So this definitely would be the simplest one we could probably get out of that. Nope. Nope, they're both still correct. My answer out of this was I'm not going to try to predict which answer would be a multiple choice answer. If this is a free response question, they are all equally as correct. So the only reason I try to teach you guys how to simplify further is because some multiple choice answers feel like they go overly aggressive on simplification. And so I wouldn't be shocked if that last answer I have is the multiple choice answer. So I'm only trying to teach you guys, or, I shouldn't say teach you, get you used to the fact that simplifying sometimes can be like just a crazy thing that can look all sorts of different ways. They're all equal. It's almost just like the eyes of whoever wrote the question, which one's preferable. So, but on my test, I'll take all of those. I'm totally good with that. Like, those last two simplifications just basically are like just changing it around. It's not even simpler. So, I don't see the point in that, no. I mean, I know that's not a great answer, Caitlin. It's just almost like on multiple choice questions, it's unpredictable sometimes what type of answer they give. Because the AP test is made up of like hundreds of people that create it. And so they kind of they decide as a group how to write answers and things. Okay. Honestly, this is probably about as hard as one I could think of, and it actually worked out good. It's just combining trig functions is the difficult part at times. I did put the outline in my notes for today. I didn't know if anybody wanted me to cover that or go over that yet. I didn't know if you were mentally ready for that. I'm also going to be on tomorrow at 10 o'clock. And again, you don't have to come in any which way. I basically was just going to be there because I know some people are getting nervous about the tests in Calc. And so I figured I'd be there to just answer questions if you're getting stressed. Do you guys want me to go over the outline today? Does anybody have a preference? I don't know how far behind you guys are. I mean, I can look it up. I just didn't want to. Yes? Want to go over it? Okay. I'll put it this way. If you are ready to go over the outline, I'll go over it now. You are welcome to leave the video chat if you haven't finished the unit yet. Going over the outline might not help you. I don't know. So if you're not done with the unit yet, it might even be a good idea for you to take the next 45 minutes to work on trying to finish the unit. But I can certainly go over the outline and go over what kind of things need to be done to find answers. Actually, this is I bet you some people in here are slightly different from yesterday, although it's pretty much the same people. If you guys had a chance to try out the math keyboards, this whole test is going to be in Schoology. And I did not write them on here for some reason. So maybe I'll look it up before tomorrow. I don't think any of these were multiple choice. I know some of them are short answers. You know what? Let me pause the recording so that I don't accidentally put all that stuff on the recording. Okay, for the test itself, there are going to be 5 multiple choice. There are going to be 5 free response, where you have to show all work. So FRQ, whatever you want to call those. And then there are going to be 4 short answer, which short answer just means you put the number answer. So these are the four at the end are like those ones that are auto-graded. So like if you put in an answer of 10, it'll grade it right away because there's just a single number answer. So the ones that obviously are going to be different are these FRQ ones. So the 5 free response questions are what I had you guys practice in that practicing out test questions or whatever it was called. The multiple choice are basically 1 point each, and there's no work that needs to be shown. It's just right or wrong. Short answer, I think, I can't remember if they're 1 or 2 points each. But again, no work needs to be shown. The FRQ, all work needs to be written in the problem. So, like if you're doing product rule, you would write in the steps of the product rule in the problem. Jeez. So that's basically what I had you guys practice writing the other day. In that testing out test questions thing, that's kind of how you would show your work in a problem. You basically just enter a new line, write the problem, enter a new line, and that's how I'm going to grade it. So I'll be able to grade it directly on there. I don't know if that. Time limit. Yes, somebody asked about the time limit. It's 3 hours. So time limit shouldn't be an issue at all. So the reason I'm giving you a huge time limit on this one is because I know some people are really slow at typing in the FRQs in the math keyboards. So myself as a teacher, I've had a lot of practice. You know, I've been typing in math equations for 20 years now. So it's definitely a lot quicker for me, and I'm used to it. The test itself shouldn't take you more than an hour. I mean, I'd be shocked if it took you more than an hour. So I'm giving you basically 2 hours to be able to type stuff in, so it shouldn't be an issue. So don't stress about time. I basically just have a time limit on there so that you're not leaving it open for the whole weekend or something, you know, like whatever. The only downside, the biggest downside I see about having to do the test on the weekend is if you guys have an issue. Like, I've pretty much been purposely trying not to read my emails and messages at night, because it gets to be too much. Like working at home this year feels like I'm basically working 24/7. Like at the beginning of the year, I tried keeping on my messages and emails all day long, and then that's basically all I ended up doing. So I've been purposely trying not to read messages at night. But I don't mind getting messages. I just reply to them in the morning. So I'll probably try to check my messages and emails a couple times this weekend to see if anybody had an issue with their test, so that I could, you know, like if it kicks you out, I could delete your test and have you start over. I don't think it lets me unsubmit, but I could be wrong. Okay, I don't know. Does anybody have any other kind of questions on the test? Maybe that they're about the layout or details of it, not the actual questions. Okay, if you do, just either just say it out loud. Writing in the chat, I don't always see it, so, but you could certainly type it in there too. Okay, so question number 1 on the test is you finding the equation of a tangent line. Well, to find the equation of a tangent line, you need 2 things. You need slope, and you need a point. Haley, we'll start with you. Jeez. Haley, how are we going to find the slope in the problem? Almost guaranteed. Probably not. I mean, and maybe you mean it correct. Calc-wise, what have we been doing lately, like a million things of? Yeah, yep. And maybe that's what you meant by delta y. I don't know. So the derivative is what's going to be used for you to find the slope. So you're probably going to have to find the derivative and then plug in an x value to get the actual slope number. Now, the point can be found one of 2 ways. One you could be given it. Or 2, you'll be given an x value, which means you have to find the y value. So those are the most common setups, but it could be different. Like you used to get some of these questions a while ago where it would be parallel to something, things like that. Basically, there's different ways of finding slopes and points, but these are the most common. I'm trying to think of a good way to do this one. I don't even remember what the question on the test looks like. I'm going to feel really annoyed with myself if it's basically just like this. But say you have a graph like this. The question you're going to be asked is, discuss the continuity and differentiability at x equals 2. And obviously it could be a different spot. It could be, the picture could look totally different. For this one, you 100% can answer them separately. So, like if you want to look for continuity first, well, it's not continuous there. So we would say this is not continuous. Differentiability. Now, if you remember, this would have the same slope before and after. So it would kind of seem like it's differentiable. But to be differentiable, it has to be continuous. So this is technically not differentiable, strictly because it's not continuous there. And I do remember that question 2 is a multiple choice, and that there's going to be 4 choices. Continuous and differentiable. Continuous and not differentiable. Not continuous, differentiable. Not continuous, not differentiable. So you're basically going to pick one of the 4. And this spot could look totally different. This spot could be a sharp point. This spot could be a gap. Basically, you just need to be able to identify from a picture if something's continuous or differentiable. Does somebody have a question on one of those that maybe, I don't know, you're not sure of something or other? Would it be continuous and differentiable? Yes. Yep. So if I asked you any other x value on this same picture, then every other x value would be both continuous and differentiable. Because basically, if it's a normal, smooth line, it's both. So the only not differentiable pretty much boils down to 2 different things. It's either not continuous, or it's like a sharp point. Because to be not differentiable, it has to have a different slope on the left and the right. And other, if it's a continuous line, the only way that they're really going to be different is if it's a sharp point. mean, I'm trying to think in my head any other like loophole, but I want to say a sharp point is probably the only way that can't happen. Because if it's not continuous for some reason, whether that's a hole, a gap, asymptote, then it automatically is not differentiable. Is that what? Oh, yes, you are right. Yep. Nope. You are 100% correct there. Vertical line. Good call. Yep. We put that in our notes, I believe. Yes, a vertical line would not be differentiable, just kind of by definition, because it has no slope. Yeah. Good memory. I know I saw a question pop up there, but I didn't see it. And if I click on it, it'll be in the recording. Do you want to copy and paste that, whoever typed it? Oh, all right. Huh. Nice. I like you guys. You guys remember stuff. Okay. I'll erase this stuff. But yeah, absolutely ask any questions away. And if it works out, that we don't get to finish the outline today, I can certainly just continue tomorrow or whatever too. Okay. Estimating derivative from a table. So estimating derivative from a table. If I did one of these in our notes, and so I don't know if you remember it, but this basically is like algebra 2 slope. So you're basically going to pick the points around it. And do old school slope. So this is a way of it's called a derivative, right? But we know that derivative kind of equals slope. So we're okay. Get out of the way. Derivative means slope, so you can certainly do it the old way, and it still represents the derivative. So number 3 generally is a decently easy one. I can't remember if this is multiple choice or just like a fill-in-the-blank number. I wouldn't be surprised if this is a fill-in-the-blank answer, because everybody should have the exact same. Continuous differentiable at a point equation. This is the exact same thing as number 2, except you're not given a graph. You basically have to look at the equation to determine if it's continuous. So you would look for anything that would be a discontinuity, whether that would be a hole, an asymptote. This might be a piece function, so you would have to check to see if the piece functions meet up. You know what? Do you want me to come up with an example of something similar to that? Like I could try to make one up. It might not even remotely work at all, but. Okay, so this one you would be asked about the continuity differentiability at x equals 3. But I shouldn't even say that. It doesn't necessarily have to be x equals 3, but that would be my guess. Because traditionally, if it's a piece function, they want to know about at the piece function break. So continuity, first thing I need to do is I need to check if they meet up at x equals 3. So I would plug 3 into both of them to start with. So if I plug 3 into both of them, I'd get 1/3 and I would get 5. Automatically they don't match up, so then this would tell me this is not continuous. Now because I made this example up, it didn't work very good. You know, like I would most likely try to create a question where they would meet up and be continuous, but who knows? So because it's not continuous, automatically it's not differentiable at 3. But let's pretend that they do meet up. The way you're going to check for differentiability is you're going to take the derivative of both of them. So the derivative of 1 over x, well, that's x to the negative 1, so its derivative would be negative x to the negative 2. The derivative of x plus 2 would be 1x, so it'd be 1. Well, and then I would plug x equals 3 into both derivatives. So in this particular one, it would be negative 1/9. On this one, at x equals 3, the slope is 1, because it's at 1 everywhere. So these do not have the same slope, so this would not be differentiable. That's basically how you're going to check on a piece function. I'm trying to think of other examples. Maybe you might get an absolute value question. So an absolute value question, you would have to find the slope on either side of the absolute value. Might be a step function. Step function would not be continuous at all the steps, but slopes are all basically the same. Continuity and differentiability, you check for discontinuities, and then you check for derivatives and slopes to see if it's continuous and differentiable. Can I make the eraser paper? Oh, there we go. That is not really that good. Okay, 5 and 6. My guess is those are pretty self-explanatory. You're finding the derivative. So that could be the derivative of a polynomial, could be derivative of negative powers, could be derivative of a root. So I can almost guarantee the main portion of these ones that just say derivative is the power rule. So you've got to write them in so that the power rule can be used. And you very well might need to use derivative properties. So like to separate the two terms, you might have to do multipliers. These are basically just regular questions. Derivative properties from a table. So we did one of these in our notes. It basically is going to be something that looks like that was actually set up terrible. So you might be asked to find something like, find the derivative of 3g of x minus 2f of x. And the derivative of that would be 3 times g prime of... I'm dumb. There we go. So that you would just fill out this stuff from the table. Oh, you know what? Your table is going to have f and g as well. I remember why we just this felt fresh. We just did this when we did product rule yesterday. So if this problem was a product rule, then you would need f and f prime, and this would be asked at x equals 1, because that's what the table is from. So we've done quite a few of those ones from the table, so I feel like you guys would probably be pretty familiar with those if you've been doing the work. They're usually straightforward. tangent line, number 8. It doesn't say equation of a tangent line, so I'm wondering if it's just a question about the tangent line itself. So like maybe what is the slope of the tangent line? I mean, I could be wrong. I don't know why I wouldn't have written the equation otherwise. 9 and 10 is just like 5 and 6. 11, I just showed the example for 11, product rule from a table. If you did the homework from yesterday, 12 and 13 is just straightforward quotient rule. And then 14 is product rule. All the above. So when it says derivative, it could be. Oh yeah. No, Caitlin, it definitely is. So basically, it's going to be assumed that trig is part of any question from here on out. Trig is not usually going to be viewed as something separate. I don't remember off the top of my head which ones have trig. But any one of these could have trig derivatives, because the whole unit is about derivatives. And so today we learned all 6 trig derivatives. So you could be asked about any of them. So basically just have those 6 trig derivatives written down. And while you're doing a derivative, if it asks you for the derivative of cosecant, you just look up what the derivative is and put that in place of it. I don't know, does that kind of make sense? This quotient rule could be trig quotient rule. It could be a combination of polynomials and trigs. Anyway, I guess I don't really treat them much as separate because they're just part of a lot of questions. I don't know. I'm trying to think if there's any other questions somebody might have out of this that. I believe 30. Almost all of the points are these 5 FRQs. Good Lord, what have I been writing here? Because your multiple choice are 1 point each, and your short answer are. You know what? I'm just gonna go out on a limb and say this is 21 out of the 30 points. And that's just kind of an educated guess, but I know the 5 multiple choice are 1 point each, so that would be 5 of the points. I'm pretty sure the 4 short answer are 1 point each. Yeah. Oh no, the FRQ are partial credit for sure. That's why there are more points. The whole reason I made the multiple choice and short answer only like 1 point was because those are all or nothing. And because there's no work shown on the multiple choice, it would be difficult for me to give partial credit. The FRQ, the partial credit you get, is strictly from your work. Like on the AP test, they don't designate points to the final answer on FRQ. The points are designated by doing the correct steps, like what portion of the problem you've done correct. So definitely, yes, I definitely do partial credit. Basic simplifying is absolutely acceptable. So yeah, I mean, like, I would just expect you to write things down that I wouldn't expect you to do in your head. I mean, like multiplication, addition, that kind of stuff, you don't need to write that down. Good question. It is absolutely acceptable to me for you to leave it as a root or a fraction power. To me, they're both correct. And same with negative powers. I am not going to require you to move negative powers. I'm not a fan of proper form. I'll put it that way. If you guys want to write answers in proper form, obviously I'm good enough to know if it's still the correct answer. But I'm not going to require you guys to. No. Good question. Okay. I guess I can't think of anything else off the top of my head. I'll stay on here till 11:15 if you guys want to ask me any other questions. Otherwise, I'll come back on tomorrow at 10. And if nobody comes, that's fine. I'm not going to take it personally, or I just figured I would be there in case somebody's stressing out about something. So if I don't see you, have a good weekend, have a good test, and if I see you tomorrow, I'll be happy to answer questions.